stored on the cloud. Okay, so welcome back to the second lesson. This is just what we left on the first lesson. So we spoke about points. We just had a brief introduction to the interface of Dynamo. And today we are going to move to something more interesting like curves. And in this second lesson, I would like to explain also some simple coding syntax in order to make the workflows a little bit better, a little bit easier to understand, and to start to understand how to implement some small script inside Dynamo. So let's go directly to the main lesson. Starting from today, I will use both nodes and code blocks syntax. So I'm just trying now to explain what is code blocks. So as you can see, the point is just made by some inputs and can have some output. And there is a name here which is the name of the library, which is points, and by coordinates is the method used by this library to create a point. So there is a special kind of node which is called code block, and you can find it going into the library under the code block inputs. Or you can just double click in the middle of the canvas, which because code block is one of the most used nodes. So we have like a shortcut. So just double click with your left mouse button, and you can have a kind of empty script which is ready to accept your information and your code. So if I want to use the code block to create a point, I can use a language called design script. So everything inside Dynamo is made by using this design script language. And everything all the names of nodes are based on this design script. So if I want to create a new point by coordinates using the code block, I can just start to write PO, and you will see that immediately you will get the point. Then I can write dot by coordinates, and as soon as we write down point by coordinates and we open the first bracket, we have different types of inputs for this point by coordinates. Eventually it's the same like in the library, because as you can see we have two types of point by coordinates. There is one with two inputs, X and Y, and is a 2D point. And there is another way to do it, which is X, Y, and Z with three inputs, exactly the same that we are using here, using three different double number. If I'm going under the library and under geometry, point by coordinates, I can see that we have exactly two types of point by coordinates, one with two inputs and one with three inputs. So exactly the same. Everything is here under the main library, the geometry library especially. We can use it as a script in a code block to automate different kind of design. So let's see, we want to create a point in the 0, 0, 0. We have a chat. Where can I find the design script language again? So it's included in the Dynamo. You don't have to find anything. You can find the code block under the inputs. So if you write down code block in the library, is under the input library. So core input code block. But it's very easy to find it because you can just double click, so 2 clicks in the middle of the canvas, and you can get the code block straight away. So if I want to create a simple point in the middle of the canvas, I can use both of them. Exactly, if I delete this point by coordinates, you can see that I still have my point by coordinates in the middle of the canvas made by my design code block. And exactly the same, if I want to create another point, I can do exactly the same made by coordinates. And for example, I can move it 10 points on the X and 0, 0 on the Y. So immediately I can see that I have the new point. Is exactly the same like doing point in this way, and then copy and paste another point, and then add a value with a slider, for example. So a number slider, and write down 10 here. And this is exactly the same. So I can remove this one. If I don't want to remove from my script something and I just want to hide something in the canvas, I can select a node or a list of nodes. In this case, we have 2 different nodes, so 2 points. And I can right click and remove the preview. So at this point, the node is gray, is still running in background, but we can't see now the point in the canvas. So the same, I can hide the preview of these 2 points, or I can hide the preview of this point. If I want to hide more than one node, I have to select both or all the nodes together and right click outside and say show all geometry preview, or select and right click outside and say hide all geometry preview. So don't try to click on top of a node because that won't work exactly. So select, then right click outside and then show, or select, right click outside and hide. So this is the best way to try something and to try to hide whatever you don't need. So if we want to use these 2 points to create a line, we have to store the value of this point into what is called a variable. So we can call P1 the first point and say that P1 is equal to point by coordinates and then 0, 0, and 0, and then close the first line, so execute the first script using a semi-comma, and then we can say P2 is equal to point by coordinates 10, 0, and 0 again, and create the second point. And then finally, if you remember, we use the node line by start point and point to connect those points into a line, which is exactly this line. So in the same way, we can create a line using the design script. And we can create a line, say that my line is equal to line point by start point, end point. Oops. Line dot by start point, end point, and then open the brackets. And as you can see, he is waiting for 2 points now. He's waiting for a start point and then end point, exactly what is written here in the node. So we do have these 2 points, and one is P1 and the second one is P2. So the final result of this code is exactly the same result that we can get with this one. So if I'm going to hide now this preview and unhide this one, activating the preview, as you can see, we have now the new code. So this is a very powerful way to write small piece of scripts just to avoid to use too much nodes, especially when we have mathematical formula or we have something very simple to write down. So we can just automate this piece of scripts like a snippet. So there is another way to insert into this inputs another input from here. As you can see, we have only output here, but we don't have any kind of input for this code block. We can automate as well the input in the code block. So for example, we want to connect this slider as we are connecting the slider to the node. So if we want to create an input for a code block, we can just change a number value with another variable. So we can call this as x2, saying that this is the x coordinate for the point number 2. As soon as we click outside, you will get immediately an error because he's saying that we don't have any value for the x2. And this code block cannot be executed because of this. But if we connect this value to the x2 value, then we have a new input. So our code is running exactly like the previous one was running. And in the same way, we can connect this and create y2 and eventually z2. So if we want to connect the same value to the all 3 inputs, we can get again the same line that we got at the end of the previous lesson. So code blocks are really powerful way to execute something using a kind of snippet way to write down the informations. But let's see what we can do with code blocks. We can do many things. So what I'm going to show you now is how to create multiple points together using what is called a range of number. So let's start again from scratch. Again, I want to create a point. This time I will use a point by coordinates. And I want to use a range of number. So there is a specific node for range in Dynamo, which is called exactly range and is still under input. So the range is a specific node to create a list of numbers. So there is a start number, end number, and step number. So the first default range is starting from 0. And you can see that the default value for start is 0. The end value for as a default is 9, and the step value is 1. So the final output is a sequence of number starting from 0 to 9. I have to give you an advice about this because as you can see, let me try to start from 1 and go up to 10 with a step of 1. What is going out from this node is actually what is called list. A list is a sequence of elements. Can be numbers, can be points, can be whatever is a list of elements. It doesn't matter the real entity which is stored inside the list. All the lists have indexes. So to get the number 1 here, I need to get the item at a specific index, which is number 0. So be careful with indexes, because all the indexes start from 0. As you can see, we have 10 numbers here, but the highest index in the list is 9. So if I want to extract a number from this list at a specific index, I can use a node called get item at index. And in this node, I can give a sequence as an input, and I can create a code block with a number inside to be able to extract at a specific index. And what I was expecting is exactly the number 1. So if I'm trying to extract a number with an highest value of index, because actually I know that we have 10 numbers here, and I want the number 10, I have always to get the number of element minus 1, always, because the lists start from 0 and not from 1. So this is a kind of syntax in the programming languages. All the lists start from 0. Sorry, and as you can see, we have a specific error saying that the parameter index is greater than the size of the collection. So if I want the latest one, I need to get the index number 9. We will come back to indexes later and lists later. Now let's try to start to understand how to use range to guide points. So we have a range starting from 0, finishing at 9, and with a step of 1, which is if we try to connect a sequence of numbers to the X, we can get exactly 9 points. Oh, sorry, 10 points. And this is because Dynamo is taking care of cycling inside this range and saying, okay, the first point has X equal to 0. The second point has an X equal to 1, and so on. If we are going to check on the output of this point, we can see that X is moving exactly in this way. So 0, 1, up to 9. If we connect this same sequence to the Y value, we will get exactly the same. So the Y and the X will grow in the same direction. And again, if we connect to the Z, we can get a bunch of points pointing all in the same direction with a linear progression. So you can imagine that in this X value or Y value or Z value, we can insert any kind of formula, for example. But how we can control this range? So we can say, for example, that we want to start from 0, and we don't need actually to put it down because it's already the default value for start. We want to reach the number 20. And for example, we want a step of 0.1. So we can connect this value to this. And in this way, let's remove from this one, we can get a higher amount of points, all of them with a distance of 0.1. And every time we are going to change this value, this distance will change. So this is a very powerful way to manage range and to draw points in the canvas using range of number, because this range of number we will see now can come from every kind of mathematical formula or equation that you want to use. There is a specific way to create range of number using code blocks. So let's try to create a range using a code block. So we can hide all geometry preview from here, and we can use code blocks, same way. So it's very easy to create range using code blocks. We need to write the start number, then 2 points, then the final number, then 2 points, and then the step value. So this is the exact syntax to write a range. And the output is exactly the same like the first range value. So if I want to change the step value, I can write 0.5. And I will have exactly the same. So think that how it's easy to write things using code blocks in this way. If I want to change this value into an input, I can just change it using a string. So this can be a start number, for example. So now my start number can be 0. Then this second number can be end number. And again, I can connect this one as an end number, as I'm going to connect it here. So we have the same exact way. And this one can be the step value. And connecting this one, we have the step value. So keep in mind that code blocks can do almost everything in the same way you can do with nodes. And as soon as you will get a little bit more confident with Dynamo, you will see that code blocks will save your life a lot. We have another way to create a range of number using code block. It's the way that we can create a specific amount of numbers between the start number and the end number. So the same way we used this code block. So we have start number dot dot end number dot dot. Then we want a specific number of numbers. So number of numbers. Let's call it in this way. And the way to explain that we don't want a step value, but we want a specific subdivisions between the start number and the end numbers is using the hash character. So let's say we want to start from 0. We want to reach 10, and we want exactly 5 subdivisions. So start number, end number, and subdivisions. So the result is completely different from the previous one. So we have 0, the first number, 10, the other number, and the total amount of numbers is 5, which is different from the step value. So if I remove this hash, then my step value will be 5 and not the number of subdivisions. So remember, it's critical, the difference between these two syntaxes. So sometimes you need a specific number of subdivisions. Sometimes you need a specific range of number. So this is the way to explain to Dynamo that you want these two different lists of elements. And then you can use these informations just to connect to a point and to draw this point. So as soon as I'm going to change this, I can get more subdivisions or less subdivisions. So keep in mind that these numbers will drive the number of subdivisions for our list of points. Well, but this is something really simple. So it's really annoying because this is a straight line actually. So I can just create 2 points and then connect these points with a line. But what if I want to manage to have a formula, an equation that is driving the X direction or the Y direction? So let's see what we can do. And we can use, for example, the sinusoidal equation to draw a line. So first of all, we have a point. And then we have something which is driving the X direction and something that is driving the Y direction or the X direction. It doesn't matter actually. So to drive the X direction, we can use a range of number. So we can create a range of number starting from 0 and going up to, let's say, 360, which is the maximum amount of degrees that we have in our formula. And the step can be 1. So again, this can be the start number. This can be the end number. And this is the step. So starting from 0, going up to 360, and the step is 1. So we can connect in this way and have our range. We will change later this code block with the number slider or integer slider. And this is actually what we need to drive our X direction. So Control B, okay, it's quite big, it doesn't matter. Then we need to use the same number to drive the equation for the Y. So how we can use mathematical equations in Dynamo? We have a couple of nodes under our core functionalities under the math library. We have cosine, we have sine, we have arcotangent, tangent, and so on, exponential, and blah, blah, blah. So if we want to create a sinusoidal equation, we can just use a sine, and then we can give this value as an angle, and then connect this to the Y. If I'm going to check my line is exactly a sine line. Just the amplitude is very low. So that's why we can't see actually the real line. So to create an amplitude, for example, we want to multiply this value for a number. So we can use like a multiply operator. So we can multiply this value for something that is an amplitude value. Let's say we want to multiply 10 times. And this is now the value that is driving the y direction. So as soon as I'm changing the value of the amplitude, this curve is getting more and more visible. So I want to connect this not to the X, but probably to the Z, which is kind of easiest way to see it. So moving this value will change the amplitude. And finally, I can add to this one a phase value. So before starting the multiplication, the real formula will be this value plus a phase. So let's add the value, this value, to, for example, another value, which is 10. And this is going to be, so we can say 30, for example. Sorry, this one to this, and this one to this. Where are you? Here it is. So this is the phase, and this is the amplitude. Let's remove this one, otherwise it's not very easy to see it. So if I'm going to move now to 500, for example, our curve will continue and so on. So this will be 600. So I can change, for example, the phase again. Let's remove this one. Let's move this. And I actually want to add the phase here. Like, let's see, can be here. So let's add this with the phase value right here. Okay, now it's working. So again, from scratch, this is our first range going from 0 to 360. And this is our phase value, which is adding a value to our first number. So the first time will be not 0, but will be 30, and so on. Then we calculate the scene value of this, and we multiply this final value for an amplitude value to guide the Z. We can do the same for X to get a strange line, for example. So this is a simple way to create a list of points following not a linear curve, but an equation. But actually, we want to create a line following these points. And to create this, I'm going to introduce now a new kind of geometry. So remember, in the first lesson, I said that the point is the easiest, the smallest part of a geometry. Then we have connecting multiple points, we have curves. And connecting multiple curves, we have surfaces. And connecting multiple surfaces, we have solids. So now is the time to move one step and go from the points to a curve. actually the best way to connect points in Dynamo to create a perfect geometry is to use Nurbs curve. So we have Nurbs, and we have different type of Nurbs. So Nurbs curve are specific mathematical curves with a specific degree. So the easiest way to connect points is a linear interpolation. So let's move this one to 10. So I have more, I have less points and you can see it better. Eventually 20, it's even 30. So I can connect points using a Nurbs, and this Nurbs has a degree. So the Nurbs of degree 1 is a linear interpolation between two or multiple points. So as you can see, from the point 1 to the point 2, we have a straight line. And this is because our Nurbs is set as a degree 1. If we want a quadratic connection between points and we have more than 3 points in our curve, we can use a curve of degree 2. Remember, you need always at least 2 plus, n plus 1 points according to the degree. So if you want a linear interpolation, so you want a degree 1, you need at least 2 points, because otherwise you can't connect with a line. If you want a degree 2, so is a quadratic curve, you need at least 3 points to be able to connect, because what we'll do, Dynamo will interpolate these 3 points using a quadratic curve. So the connection between points will be a little bit smoother, but not all the points will be touched, because if you think about these points, we can see that we have these 3 points interpolated by a curve. But then starting from these second points, we have again 3 points which will be interpolated, and so on. So as much as we are moving forward with the points, we have a smooth interpolation, but is a curve like not touching all the points, because every time is trying to interpolate different points. So moving to the degree number 3, so we need at least 4 points. This line is going to be smoother and smoother and smoother. And to be able to have a more accurate line, we need to increase the number of points. So these points right now are very far from each other. If I'm trying to reduce even more the number of points, you can see that the line is moving from the points because it's trying to interpolate less points. So we have a very small amount of points that we need to use to interpolate. But if we try to increase the number of points, so we can say that the distance is 10, as much as we increase the number of points, this line will be smooth, but will be much more close to the points as well. Because the 3 points that we are trying to interpolate are almost on the same tangent. So if I'm going to use, for example, 1, you can see that this interpolation is more or less perfect. And even if I'm trying to use the degree 1, if the number of points is enough, we can even have a smooth curve using a linear interpolation. So it's just a balance of number of points and type of interpolation to have a best curve. So I can just hide this point now, for example, and see only the curve. As much as I'm reducing the number of points, this will be smoother using a value of 3, which is a cubic curve. And if I'm trying to increase the number of points, this curve will be much more close to what we need. So it's just a balance. But keep in mind that the amount of points can increase a lot based on the distance between the points. But how we can do this using code blocks, for example? So let's try to see if we can use this one with a simple way using code blocks. So again, we can keep this as an input and we can start our code block from here. So what we need now is to input this value and then add the value for the face and then calculate the scene function and then multiply for an amplitude. So we need an X value as an input. We need, for example, a face value, and we need an amplitude value. So this is my face value, this is my X value, and this is my amplitude value. Now we can calculate the scene, which is exactly how we are going to calculate it here. Math.scene. So is math.scene. Here we have the X value plus the face value. Remember, this is case sensitive, so be careful when you write the names of variable, which should be exactly the same. And then we need to multiply this one. Oh, where is? Multiply this one for amplitude value. As you can see, I wrote the name in the wrong way. So this should be value. So if we have any kind of error here, is because something is written in the wrong way. So I used S with not a capital letter, so I just need to change this into a capital letter. So be careful, you have to write in the exact same way. And this is the same list that we are getting outside from this node, but in a very easy way. We can even remove this tree from here because we already have this value in the formula. So we need only one single line to do this. So this is my Y value equal, or just Y equal to. So the X value is this, the Y value is this, and now we can create our point by coordinates using, I'm sorry, this is the Z value, X value, which is exactly this one. We are using no value for the Y and then the Z. So this is drawing exactly again all the points. And finally, let's remove this one. Finally, we want to use a Nurbs curve by control points. So our Nurbs curve dot by control points, and we need to input the list of points and the degree. So first of all, we need to say that this is a list of points. So we need to use a variable for this in order to be able to use it in here. And here we can say points, and the degree, for example, is number 3. So again, this is acting exactly like this one, but with code block. So I don't want to force you to use code blocks from the beginning, but I just want to try you to understand that this is where you are going to finish to end your Dynamo course, because this is really important to understand. If you can manage in the right way how to use code block and when to use code blocks instead of using nodes, you can easily manage your workflow and make it very simple. Right now, we want just to change this into sliders. So let's say we want number slider 3 for this. So the first one can go from 0 to, okay, 100 is okay. The other one can go from 0 to 1000. The step can be only 1. This can be only 1. And the final one can be again up to, let's say, 100. Just some numbers that can make sense. So I can connect this to this. Let's say this is already 360 or something, and the step of this is probably something like 7. So I can remove this one. So this is the face value. Again, I can have a slider here for the face. And finally, this is the amplitude. So I can have another slider for the amplitude. Well done. So now we can move this to change the amplitude. We can change this one to make it longer. For example, and we can change this to make it smoother, even closer to what we are expecting, or reduce the number of points. And then we can change the face of this. So changing the face, let's go to 360, for example. Changing the face, we can see the curve starting from a different point. And this is just what is a parametric curve. So starting from this, we will see later how to build a surface, how to build something that is even more parametric, but in the third direction. So right now it's just a simple curve. If you want to be even more parametric, you can use an input from 1 to 3 for this value. How you can do that? You can just use a number slider and say, I can go from 1 up to 3 with a step of 1. So I just have 1, 2, and 3. And I can say that this one is the degree. And I can just connect this one. So changing this, I can have a smoother curve. I can make it, I can make more points. I can make it even longer or shorter. So I can control more or less everything about this curve just using a bunch of sliders and 2 code blocks. Actually, this can be even 1 if I'm using this as saying that the X value is equal to this. So then I can connect start number, end number, and step to this one. There is a cyclic dependencies. This is strange. Let's use it in this way. So sometimes when you start to connect things in the and you are in the automatic system, you just get some error. So it's better to save like lesson 2 and then try to reopen. And now it's working again. So this is just a little bug of Dynamo. Sometimes you are getting this kind of issues. So I can go into manual and say that here the X is equal to this value. Control C, Control V, and say that this is here, this is here, and this is here. Remove this one and say that this is the X. So start number, end number, and this is the step. This is the phase. This is the amplitude. This is the degree. And this is again the X. So I can remove this one and use just one code for this. Pretty easy, pretty nice. So I can move this like a snake up and down. And if I want, I can also change the kind of formula using the cosine. So it's just changing the shape, but the result is more or less the same. So pretty good. The last thing I want to show you is how you can comment your script, actually, because it's really important to use comments in scripts. So I don't know exactly what is this number slider. Yes, I can say that this is connected to the start number. What if this is connecting in a very big and huge script where this node is something right here? So I can only see this and I can say that this is the start number. So there are 2 ways to do this. The first one is to place nodes. So I can place and create a new node using edit create node or control W and say that this is the start number, for example. And I can keep always this on top of the number slider. The other way is to do a double click directly on the node and say that this is the start number. So I can get rid of this and I can say that this is the start number. Pretty easy way to do it. There is a final way also to collect elements together and create groups of nodes. So once I finish this one, I can say this is the end number and this is, we said, the step. This is the phase. This is the amplitude, and this is the degree or curve degree. So once this is finished, I can select all these nodes together and I can create a group, Control G. So then I can group together things and I can even give here a description. So those are my inputs. And I can even right click this group and check and select the color for this. So I'm always using a color coding for groups, like for example, using the gray for inputs, and I'm using always kind of magenta for outputs in Dynamo. And if I have output in Revit, I'm always using, for example, a bluish value. And if I have some mathematical equation or calculation in Dynamo, I'm always using this green color. So when the script is growing and is becoming very big, I'm always trying to use this color coding to understand what is an output, what is an input, where something is happening in Revit or something is happening in Dynamo, and so on. But you can choose your own color coding. Just remember that is really, really, really important. So I'm always using all of them. I'm using grouping, renaming nodes, and sometimes I'm also creating some note with a brief description. So this script can create a curve based on several, you can go also with a new line based on several inputs. Let's say numerical inputs. So this node is really important to be added to this group, and you can always add a new node to a group, just selecting the group, shift. So from the keyboard, you can push the shift button and then select the new node that you want to add to the group, and then right click and say add to group. So then you can just move it in the right spot. So in this way, you can have a very clean and working workflow that everybody can understand and can modify, for example. So in the next lesson, we will see how to convert a small script like this into custom nodes. And then we will start to understand how to build a surface based on different curves. And then based on this surface, just create something in Dynamo that can be a floor or can be any kind of geometry based on something that is coming from Dynamo. So let me save this script right now. I will send this script through email to everybody, together with the link to the recording of today. So let me stop the sharing. I'm sorry, not stop the sharing. Let me stop the recording.